name is Tanmay, and welcome to iOS Club. We'll be talking about making a weather app using API calls, JSON parsing, and protocols. These will be the new things we will be covering today. So let's get started. What is an API? An API is an application programming interface, which is part of the server that receives requests and sends responses regarding data, of course. So most of us have probably heard of an API or used an API in the past. And Today we'll be using Open Weather Maps API to get weather data for Atlanta at the current time of recording. And the first thing that we need to learn about API is how to call one in Xcode. For simple cases like ours, we can simply make a request to the API using a provided URL of the API on the given API key parameters that we want to query. There's also Cocoa pods like Along Fire that we can use to help us with these things. But we'll simply be using a URL session. And the other part of an API is what the data that an API returns. It's usually in a JSON format, which is a JavaScript object notation format. It is easy to pass through and easy to generate. It is both like good for computers and human beings to understand, so it is pretty popular. And as I mentioned, it is easy to parse through. So we will be also be discussing how to make a JSON parser of our own to fill in the required parameters in our variables. And there's also Cocoa pods like Swifty JSON that help us do that. And next up, we'll be talking about protocols and delegation design pattern, which we'll be using in our project today. So the Swift documentation talks about protocols as a blueprint of methods, properties, and requirements that suit a particular task. A protocols can be adopted by a class, structure, or enumeration to provide an actual implementation of those requirements. They're essentially good for reusing and encapsulating stuff. The one that we will be using today is a custom one that we build, and the encodable and decodable one protocols, which are useful for JSON data. And let and after we have the JSON data collected from the API, we need to fill in the UI with the data that we gathered, and then we should be ready with our weather app. So let's get started. And this is what the weather app is going to look like once it's done. It's pretty simple. We can have customizations, but due to scarcity of time, we will be just making a bare bone one. And we can probably discuss customizations afterwards during on the Facebook group or during the iOS lab office hours if you guys want to. So let's get started. Um, so first we open up Xcode. I am using Xcode 12 beta now since in we want to make an app. Let's call it Weather. We'll be making it using Storyboard and not Swift UI, UIKit, and Swift and not Objective-C. And I'll just save it to my desktop. Um, Let us replace it. And let's get started. First, we open up main.storyboard to create the UI labels that we need to be using to fill them up. I'm just gonna drag a label, put it here, and then drag another label and put it here, the center. We need to resize them a little bit. So center again, and make it bigger. Center, center, and increase the font size, blow it up a little bit. Center, blow it up a little bit. Just call this location, and call this temperature, just temp. Whoop, misspelling there. And next up, we want to open it up with the view controller. Make ID outlets like we have in the past. Let us call this one weather location, and this one temperature, and let us run this once. We probably, let me do this on the iPhone 11 Pro, or the one that I have loaded, which is iPhone 11. Yep, this is the one. As you can tell, we don't put in any data right now, so it doesn't really say anything. And let us add the constraints. And we will be making 3 new files to work with the API. Um, the first one is going to be uh, a Swift file called weather data. Um, the second one is going to be called weather model. And the third file is going to be called a weather manager. So the first thing that we need to do is make the weather data. This is going to be structs that will have the format in which we will be receiving the data from the JSON. Every JSON file receives the data in a certain format, and the one we will be using has a lot of parameters. The ones that are required and we need are name, the main, and the weather. So we have a struct for each of them and the ones that we need. The first one is weather data, which is codable, and the fields are name, main, no, not this main. It'll be a custom class that it'll be a custom struct that we write, and weather, which is of weather, another struct called main, uh, which is also codable. Oops. And it has a constant named temp. Not a string, it's a struct called weather, which is codable and has field description, string, an ID called int, for int, which is an int. We are mainly focused with the temperature because we don't really use the rest of this during this session. And the next thing we need to do is to work on the weather model. So in the weather model, we create a struct called weather model. And we convert the temperature into a double and make sure that we are returning a formatted string. And string formatting is covered in the introductory computer science classes like 1331. In Java, it works pretty similarly in Swift as well. You just have a float and a round off point to one decimal. And now that we are done with this, we will be working on the um, core of the application, which is the weather manager. Here we will be making the API call and parsing the JSON and doing the other relevant stuff with it. So let us make a struct called weather manager, where we have the most important thing called weather URL. And I have already gone ahead and gotten a key for myself from the Open Weather API. And I'm just gonna paste it here. So you can just go to openweathermap.org and then /API, use the free weather API. I think you get about 100 API calls a day, which is more than enough for our sake. And you will be receiving an API key, which will be your app ID, as mentioned here. And we are querying for the city of Atlanta, so which is one of the required keys. and we it would be returning in Kelvin, right? So we want the imperial system to give us the result in Fahrenheit because that is what is conventionally used. And this is the URL that we will be using. And now we need to make a function called fetch weather, which will use the URL, uh, which will use the URL. Then we will be using a function called perform request that we will be creating ourselves with the URL string. And now let's work on the perform request with URL string, which is of type string. Um, and we get the URL. We initialize it and let session equal the URL session that I mentioned we will be using during the slides, and configure it to default, and let the task that we are performing be a session data task with the URL that we just initialized. And in data, have data response and error be there, and make sure if error, if we don't, if error is not nil, we will be using something from the protocols we create called um, did fail with error and unwrap error. And now let's create the protocol that I mentioned. So it is a part of the delegate design pattern where if there's two independent entities, they need a middle ground. We delegate tasks to be performed by something else, and that acts as a middle ground. So protocol called weather manager delegate. One function would be did it update the weather using the weather manager. And weather model that we created before. and another function called did fail with error that we used underneath, which will have an error. There is no member delegate because we have not created the delegate yet. We will be creating the delegate here, which is a variable delegate weather manager delegate optional. And if let save data, if it works correctly, then we have weather equals self dot parse JSON, which is another function that we'll be creating to parse the JSON using the safe data, that is the data that is safe to parse. Um, self dot delegate dot date update weather. We check that. Self and weather and then we resume the task. Next, let us create the function for the JSON parser. We have weather data and we return weather model, which is optional because, well, we might be returning a null value in case we catch something going wrong. And we have a decoder of JSON decoder type. We try to have decoded data. We decode from weather data dot self from weather data. Let the temperature be decoded data dot main dot temp, which is based on the structure that we previously mentioned in the previous files because of the way the API returns the data. And we let weather equal weather model of temperature temp, which we made here. And then we return the weather. But if we have something going wrong, we check if it failed and we return a nil value. Have one bug where I should not have had this here, and we should be good. Yep, we should now have the weather manager, the weather model, and the weather data working. So let us go over what we have done here, since this might be all a bit too complex to take in if you're doing it for the first time. We created weather data that takes in the JSON to have a placeholder for the JSON data to go into, and we have a weather model to model the data after, and the manager where we have a protocol to delegate updating and failing of um, the weather um, um, API calls, and we call the weather API querying for Atlanta using the app uh, app ID, which is the key uh, in Fahrenheit, and then we fetch the weather using the API URL, and we perform the request to do that, and we will be getting we'll be get when we get the data we need to parse through the JSON to get it in the right format. And now, as the last step in the slide mentioned, we need to update our UI, which will be doing it in the view controller. Um, so the first thing we need to do is make sure that the view controller also extends the weather manager delegate. And next up, we have the we if we just click that, it does it for us. We need to add the functions for weather updating and um, filling. So what we do is we dispatch um, a queue of main asynchronously. I think we have covered this once before. So where we set the strings in the UI. So we set temperature dot text as weather dot temperature string, and we also add a Fahrenheit for good measure, the Fahrenheit symbol for good measure. You can press Option K on your keyboard to get the degrees sign. Uh, it's just a little shortcut there, and we set the weather location dot text to be Atlanta, since we are in Atlanta. And if it fails, we just print the error. And the next step is to have a weather manager initialized, an instance of the weather manager, and then we simply use their methods here. So weather manager dot delegate equals self weather manager weather manager dot fetch weather, and now we should be done, I believe. Let us test it out. And as I mentioned before, you can do a lot of things with the API. You can get the weather ID to display what stuff is happening, and you can have um, a lot of things about the future forecasts too. Let us fix the constraints so that it displays correctly. Um, main.storyboard. Um, yes, it is not. Oops. It needs to be centered horizontally in the safe area as well. And this should be it. We have a weather app that calls an API and displays the current temperature outside.